Welcome to our comprehensive guide on Identity and Access Management interview questions. Identity and Access Management, commonly known as IAM, is a critical cybersecurity domain that focuses on managing digital identities and controlling access to resources. The four core concepts you need to master are authentication, which verifies user identity, authorization, which controls resource access, single sign-on, which provides unified access management, and identity federation, which enables cross-domain identity linking. These concepts form the foundation of modern security architectures and are essential for any cybersecurity professional. Let's start with authentication fundamentals. The first common question is, what is authentication and how does it differ from authorization? Authentication is the process of verifying user identity, while authorization controls what resources a user can access after being authenticated. Think of authentication as proving who you are and authorization as determining what you're allowed to do. The second key question focuses on the three main authentication factors. These are something you know, like passwords or PINs, something you have, such as tokens or smart cards, and something you are, which includes biometric data like fingerprints or facial recognition. Understanding these factors is crucial for implementing multi-factor authentication systems. Now let's explore common authentication protocols. LDAP, or Lightweight Directory Access Protocol, is used for directory access and user information retrieval. Kerberos provides ticket-based authentication using a trusted third party for secure communication. SAML, or Security Assertion Markup Language, is an XML-based standard for single sign-on implementations. OAuth 2.0 serves as an authorization framework that allows third-party applications to access user resources without exposing credentials. A critical interview question is how to implement multi-factor authentication in an enterprise environment. Focus on security layers to prevent single points of failure, user experience to ensure adoption, and integration challenges when connecting with existing systems. Authorization models are fundamental to access control systems. The main models include RBAC, or role-based access control, which assigns permissions based on user roles within an organization. ABAC, or attribute-based access control, makes decisions based on attributes of users, resources, and environmental factors. MAC, or mandatory access control, enforces policies set by system administrators that users cannot override. DAC, or discretionary access control, allows resource owners to control access permissions. The principle of least privilege is critical for security. It involves granting minimal permissions necessary for job functions, conducting regular audits to review and adjust access rights, and implementing just-in-time access for temporary elevated privileges. Single sign-on, or SSO, provides significant benefits for organizations. It enhances user experience by eliminating multiple login prompts, improves security through centralized authentication controls, reduces IT costs by minimizing password reset requests, enables centralized monitoring of user access patterns, and increases productivity by reducing time spent on authentication. The basic SSO flow follows 5 steps. First, the user accesses an application. Second, the application redirects the user to the identity provider. Third, the user authenticates once with their credentials. Fourth, the identity provider issues a token that gets verified by the application. Finally, access is granted to the requested resources. This process ensures users authenticate once but can access multiple applications seamlessly. Different SSO technologies serve specific use cases. SAML 2.0 is XML-based and ideal for enterprise web applications requiring rich assertion formats. OAuth 2.0 focuses on authorization and is perfect for API access delegation scenarios. OpenID Connect acts as an identity layer built on OAuth and works well for modern web and mobile applications. Common SSO implementation challenges include legacy systems that may lack modern authentication support, creating integration complexity. Single point of failure concerns arise when the identity provider becomes unavailable. Token management involves securing token lifecycle and preventing unauthorized access. Cross-domain issues can occur due to browser security limitations and same-origin policies. Identity federation enables secure identity sharing across different domains and organizations. Core concepts include the identity provider, or IDP, which authenticates users and provides identity assertions to other systems. The service provider, or SP, consumes identity information from the IDP to make access decisions. Trust relationships establish secure connections between different domains through shared certificates and agreements. Assertions are signed statements about user identity and attributes that are exchanged between systems. Common federation use cases include cross-organization access, allowing partners to securely access internal systems. Cloud integration enables authentication from on-premises systems to cloud services. Mergers and acquisitions require integrating disparate identity systems. Multi-domain SSO provides seamless access across different organizational domains. When comparing SAML versus OpenID Connect for identity federation, SAML 2.0 is XML-based with enterprise focus, offering rich assertion formats but with higher complexity. OpenID Connect is JSON-based and represents the modern standard, built as an OAuth 2.0 extension that's mobile-friendly and lightweight. Critical security considerations for federation include certificate management with proper key rotation and validation procedures. Token lifecycle management requires appropriate expiration and refresh policies to prevent unauthorized access. Transport security demands TLS encryption and certificate validation for all communications. Comprehensive audit and monitoring systems must log all federation events for security analysis and compliance requirements. Let's examine a practical Python RBAC example. The access control class initializes with roles dictionary containing admin permissions for read, write, and delete operations, while users only have read permissions. The check_permission method verifies if a specific role has the required action permission. In the usage example, when checking if a user role can perform write operations, access would be denied since users only have read permissions. Scenario-based questions test practical knowledge. Designing IAM for multi-tenant SaaS applications requires focus on tenant isolation, role hierarchies, and data segregation. Handling privilege escalation attacks involves detection methods, prevention strategies, and incident response procedures. Implementing zero trust access requires continuous verification, context-aware policies, and network microsegmentation. To succeed in IAM interviews, remember these essential points. Always emphasize security first by focusing on least privilege principles and zero trust architectures that assume no implicit trust. Design scalable systems that can grow with organizational needs and handle increasing complexity over time. Balance security with user experience to ensure user adoption and compliance with security policies. Implement continuous monitoring through comprehensive auditing and real-time threat detection systems. Master these IAM concepts, and you'll be well prepared to tackle any identity and access management interview question with confidence. These fundamentals will serve as the foundation for your cybersecurity career journey.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.